Today we're going to be going over how to solve a quadratic equation by factoring. So reminder, a quadratic equation is an equation that has that x squared in it that forms the parabola, right? So those U-shaped curves that we've been going on a graph, those are quadratics, okay? And factored form is what we are going to have at the end of our factoring problem, which is y equals a times x minus r1, and then we have our x minus r2. So those are our two roots when we have our parabola. If you remember, our roots are going to be the places that the quadratic touches the x-axis. And so the solution, the roots, and the zeros are going to be the x-intercepts, right? Those are all very important. We learned that acronym ROCKS earlier in the year, so we could remember all of those words, and we can find those using these numbers in factored form, which is also sometimes called root form. Okay, so the first thing is you're going to set the factors, which are going to be the parts that are in the parentheses, equal to 0. You're going to solve both equations, and then you're going to state both values as solutions. And when we go ahead and state them as solutions, we are generally going to want to do that as ordered pairs. Okay, so it says down here, special note, that if a GCF has been factored out, we do not need to set that part equal to 0, okay? So if we do have a GCF at the beginning, we don't have to worry about setting that part equal to 0, okay? So let's go up to the top and look at a few examples. This one you can see it is already in that root form. So all you have to do is you just take the two roots, 2x minus 3 equals 0, and then we have x plus 4 equals 0, and that is going to be, we'll add 3 to both sides to get the x by itself. On both of these equations, we're just trying to get x by itself. So that gives us 2x equals 3. Then we'll divide both sides by 2, and we'll get x equals 3 over 2, which you know is the same as 1.5. Over here, we need to cancel out that plus 4, so we'll do that by subtracting 4 from both sides. This will give us 0, so we'll end up with x equals negative 4. So if we were to graph this form right here, 2x minus 3 times x plus 4, if we were to go into our calculator and put that in our graph, parentheses 2x minus 3, parentheses x plus 4, that is going to give us this parabola. You can see, look right here, this is going to be 1.5 like we just saw, or 3 over 2. And then over here, that one is going to be negative 4. So these two roots are occurring at the same place that we would find them on the graph. They're not different. There's just the algebraic method of finding those two places, okay? So let's go to the next one. If you remember, if there's a GCF, we do not need to set that part equal to 0. So we'll just go ahead, 3x plus 6 equals 0, and then x minus 5 equals 0. So here we'll have minus 6, 3x equals negative 6, because positive 6 minus 6 is 0. Then we will divide both of those by 3, x equals negative 2. Okay, here we have plus 5, so we will go ahead and find that this one is going to be x equals positive 5. Okay, so our two solutions are 5 and negative 2. Sometimes you'll see them as ordered pairs, which will give us, they would be 5, 0 and negative 2, 0, right? So those are our two solutions. Here you can see this needs to be factored. Okay, this is not already in factored form. So you got to think back to what we did before spring break, and you can remember that we would say, is there a GCF? Well, 3, 17, and 10 don't have anything that they can all divide by. So what I'm going to do is I'm going to go ahead and put all of these into my box. Okay, so I know that that 3x squared is going to go in this part of my box. I know that my 10 is going to go here. And I know that these two are going to add up to be 17, but I'm not exactly sure yet how we're going to break them down. In order to find that out, I have to come here and say A times C adds up to B. Okay, my A is 3, my B is 17, my C is 10. So 3 times 10 is going to give me 30, and then my B value will be 17. So I'm looking for two numbers that multiply to be 30 and add up to be 17. Okay, 1 times 30 adds up to be 31, so that's not it. 2 times 15, well, that is going to add up to be 17, so that is my two factors. So I'm going to put my 2x right here, my 15x here, and if I can see, the biggest thing that 3 and 15 have in common is 3, and then I can get an x out due to the fact that these both have an x here. Here I can divide out a positive 2. Okay, over here the only thing that I can take out is an x, but here I have a 5. It's going to be a positive 5. So my two factors are 3x plus 2, and I'm going to go ahead and set that equal to 0, and then x plus 5, which I can also set equal to 0. I'm going to subtract 2 from both sides, end up with 3x equals negative 2. Divide both sides by 3, and we get that x equals negative 2/3. Okay, here we're going to subtract 5 from both sides, and we see that x equals negative 5. So my two factors are, my two solutions are negative 2/3 and negative 5.